All right, good morning, everyone. Today is day 28, the end of week 7 for our online AWD 1100 C# programming class for the summer 2023 semester. Today, it's going to be kind of a hodgepodge of a period. And what I mean by that is I'm going to go over a lot of the material in chapters 13 through 16. All right, I gave you a bunch of URLs, and the majority of them are from learn.microsoft.com. Now, I like to be transparent with people, so I'm showing that I'm about to show you something I probably shouldn't show you. All right, but I am going to anyway. And that is, I sent Evan Gudmested, who is my counterpart at the St. Louis campus, I sent him an email yesterday. And this is what I said. All right. I told him that I was going to give him a test today, and the test I was going to give you, and I kind of set up what I wanted to do for the rest of the semester. All right. And now that I looked at it, I probably shouldn't be showing you all of it because it's got what will be on your next test. But the point is this: there is so much material in chapters 13, 14, 15, and 16 that I'm not really sure if we're going to be able to cover all of it in the depth and breadth of coverage that it may deserve. All right. Why am I saying that? Because after we get done with chapter 16, right, after we get done with that, we got 17 and 18. 17 is not a hard chapter. It's on file handling. We could do that in a day. 18 is on what's called LINQ. All right, which stands for language integrated or line integrated, depending on the book you read, query. And what it does is it allows you to take things that are not databases and treat them as though they were databases. Now, you may listen to that and say, fine, who cares? Should I care? Does this matter to me at all? And the answer is, yeah, it kind of does. All right. And there's some stuff in there that we'll have to go over. But the point is, by the end of next week, I really and truly want to be done with this and be into chapters 17 and 18. All right. So what I'm suggesting to him is that I do an abbreviated coverage of some of the material that we have left in here. What do I mean? Well, let me jump back to here. And I'm going to jump back to the beginning of the book. So I think at least we've done a pretty fair job of going over chapters 1 to 12 that you see in here. All right. I'm not going to cover chapter 13 at all. I've just made that decision, be it right, be it wrong. I'm not going to go over chapter 13 at all, which means there won't be any homework. There won't be any labs. You won't have to do the written test either. So in just a couple minutes when I start, I'm going to start on chapter 14, which is on inheritance. We're going to talk about that one quite a bit today. When we get done with that, I'm going to go into chapter 15. And I'm going to talk about interfaces, but almost nothing about generics. And then when we get done with that, we'll go through chapter 16. Now, if I have my way, I'd like to go through all of that today, but we'll see how it goes. All right. Now, approximately half the people in the class yesterday got a hold of me at some time or other during the test and said, either I'm having problems understanding this, I'm having problems understanding that, whatever this or that happened to be. I had people asking, hey, if I blow this test, can I retake it? All sorts of stuff. Okay. And, I didn't really know how to answer that. And I'm still not exactly sure how to answer that. I will tell you that this weekend, I will be grading. All right. And really, the only thing I have to grade is I'll go back and look and see if some of you have turned in late work. All right. And I'll go back and see if anybody has any late work. Okay. And then afterwards, I'm going to go in and I'm going to grade the test that you took yesterday. All right. If it turns out that people didn't do well, or if several people didn't do well, then probably what I'll do on Monday, when we start on Monday the 10th, is I'll do the test before your very eyes. All right. And, what do I mean? Why do I mean, etc. Well, if people aren't doing very well, the stuff that we cover in chapters 14, 15, and 16 builds on the stuff we learned in chapter 12. So if you don't understand that, it's going to be hard for you to go on. But my hope is by a week from today, we will be taking the test on chapters, let's say 14, 15, and 16. Okay. Then the following week, the week of the 17th, we'll do chapters 17 and 18. Okay, fine. During that time, what we also have to do is, and I'm planning on doing this next week, I don't know yet what day, but I'm going to give you a handout, probably two handouts. One of them will be for the final project that you will have to do in here. All right. And that final project will be due the day before the end of the semester. So the 16th of August. All right. Which is, I believe, about, I don't know, 6 weeks from today. All right. Something like that. All right. And actually, 6 weeks from yesterday, 6 weeks from today is the last day of class. All right. So I'm going to give you a thing on the project. Now, a lot of it won't make sense because most of it is based on this last section of the book. That's why we have to get into that section of the book as soon as possible. All right. The other thing I'm going to give you is a thing on your electronic portfolio. Now, some of you in this class took the AWD1100 class last semester. All right. You took the class Web Development Technologies last semester. And if you did, you already know about creating an electronic portfolio. Some of the rest of you, that's about a third of the class. And the other 2/3, this is your first class. So you probably know little to nothing about creating an electronic portfolio. So I'm going to run over that with you, including giving you the chance, if you want, to download some free software where you can just do drag and drop to do an electronic portfolio. And I'll build one right in front of you to show you how easy it is. All right. So that's what we've got to look forward to. I do want to make sure, if possible, that I think it's, again, about 4 weeks from today, which will be like August 2nd or something like that. We're done. We're done with the book. I'm done lecturing. All right. Or as close to being done as possible, so that during those last 2 weeks of class, you'll be able to work on your projects. You will be able to work on your electronic portfolio. Now, I mean, that's what I'm hoping happens. We'll see if it does or not. All right. So if I sound a little out of sync today, okay, maybe that's why. So I'm going to jump into chapter 14. So I'm going to skip this chapter. How to work with indexers, delegates, events, and operators. And by no means do I mean to say that this stuff isn't important. It is. We could easily spend a whole week on this chapter. All right. I've given you some URLs, so if you want to do some investigatory work on this yourselves, you'll be able to. All right. And I'm just going to leave it at that. All right. Starting in chapter 14, which is not a super long chapter, but they start to talk about inheritance. And that's what we're going to talk about next. Now, inheritance in C sharp, in some ways, is like genetic inheritance. All right. And what I mean is, if I declare a class, so let's just look at a real simple example. All right. So if I come in and I declare a class, and I call that class bank account as an example. All right. And then I create some other classes that maybe it's called checking account and savings account and maybe IRA account. All right. What I'm trying to show you here is if I create a base class called bank account and I say, you know what, everybody who has a bank account, they need to give us their first name, they need to give us their last name, their address, their city, their state, their zip, and let's say their, I don't know, account number. As an example, this isn't a great example, but it's not a bad one either. All right, so let's knock this down a little bit. Okay. Well, if I create a bank account class and I give it these members right here, when you think about it, regardless of the type of account you have, again, whether it's a checking account, a savings account, an IRA account, and there could be other ones. There could be a Christmas club account, a retirement account, etc. I'm just trying to keep it simple. But if I create this and then I say that based off of this class, all right, this is going to be what's called a parent class, all right, that these would be child classes. And they go by other names too. We're going to see that in just a bit. But if I create a checking account class that's a child of a bank account, or a savings account class that's a child of a bank account, or an IRA account class that's a child of bank account, it automatically gets all this stuff. Anything that I declare in bank account, I automatically get in the child or the children. Now, if I don't like the way that something is done in a parent, I can override it or change it in any of the children, right? They can even do it different ways. So if I had a thing in here that I called get, how about just account balance? Maybe the way that I figure out an account balance for a checking account is different than the way I do it for a savings account. And it's different still from the way I do it for an IRA account. So I can declare as much stuff as I want up here. And these can all be regular instance variables, or they can be methods. And if this is a parent account and I create child accounts based off of that, all right, they get all that stuff for free, so to speak. All right, so they get everything that's in there for free. All right, now if they don't like the way that something is done, they can do what's called override it. Now, we've talked about overloading before, but never about overriding. And I've given this example before. I don't know if I have to your class or not, but I'm going to give it right now, and it's going to be really simple. Okay? And it's this. All right? That if you have a man and a woman who get married, and both of the parents have a big nose, all right, it happens, and they have a child, there's at least a good chance if both parents have a big nose, the child will have a big nose. It doesn't always happen. I get that. All right, but that's genetic inheritance. So what can the child do about that? Basically, two things. Can live with a big nose or can get a nose job. It's not like the child is born with a certain nose, can take that nose off and put on another one they'd rather have. But that's kind of what you're able to do. That's kind of what you're able to do with C# inheritance. So if I get something, let's just assume in here the way that, for account balance, it might be drastically different in here as opposed to in here, as opposed to in here. Now, it's even more so than that because I gave you an example a while back that looked like this. You may or may not remember it, but we talked about a class called animal. All right. And based off that class called animal, we said we'd have a dog, we'd have a cat, and we'd have a bird. Now, there could be all sorts of other classes. I know you get that. All right. And then under dog, we could have a whole bunch of classes under there. So there could be a dachshund and a Saint Bernard and a collie, etc. Under cat, we could have a whole bunch of different cats, a tabby, a calico, etc. Under bird, we could have a bunch of different types, a parrot, a mynah bird, a hummingbird, etc. All right. But we can define things up here that all animals have. All right. So we could define things like breed, name. All right. And there could be a whole bunch of things, but we could also define just a method up here that's called speak. Now, you all know this, that a dog speaks differently than a cat, that speaks differently than a bird. But if I invoke a speak method on a dog and it knows to bark, as opposed to if I put a speak method on a cat and it knows to meow or purr, and if I do a speak method on a bird, it knows to tweet or whatever it does. All right. This is a really important concept because what we're saying is I can call the same method on different kinds of objects and it will know the correct invocation of that method based on the type of object we're using. That concept is referred to, okay? That concept is referred to as polymorphism. And that is the ability of different types of objects to respond correctly to the same method based on the type of object they are. All right. So I'm just giving you a little bit of highlights, so to speak. So let's talk about inheritance. As it says, it's one of the key concepts of OOP, of object-oriented programming. It lets you create a class based on another class. As it says here, inheritance is actually used throughout .NET. You're going to see a picture of that in a page or two. In addition, you can use it on your own classes. Now, what I'm planning on doing next week is to have us build a couple examples from scratch so you can see exactly how this works. All right, so what do we have in here? An intro to inheritance, some basic skills for working with inheritance. We're going to have an inherited version of the product maintenance app. Now, what does that mean? Well, what it means is we're going to take an app that we created earlier and we are going to create two classes based off of the class we created earlier. If you don't understand that, just bear with me a little bit. I think you will. Finally, we'll talk about object types and casting. Okay, so we're going to see how much of that we can do in the next hour or so. Then when we get done with that, we're going to jump right into chapter 15, and we're going to concentrate in there on the part that deals with interfaces. All right. And if we still have time left, then we'll go into chapter 16 and we'll talk about class libraries. There's a lot of stuff we're covering today. All right. So inheritance, as it says, allows you to create a class based on another class. And as I've already mentioned to you, in many ways, software inheritance is like genetic inheritance, except there's things that you can do with software inheritance that you cannot do with genetic inheritance. As they mentioned there, when used correctly, inheritance can simplify application design. All right. So they give you some verbiage here. We're going to look at all of it. Now, what I called a child class earlier, so when I created that animal class, and then underneath that, we put in dog and cat and bird, animal would be the parent, dog and cat and bird would be the children. All right, child classes are also called derived classes. Parent classes are also known as base classes. It just depends on the book you read or the article you're reading, etc. And it's just, I mean, it's just word salad. It really doesn't matter what you call them. So they show an example in here. And let's look at the examples that they give. All right. So it says we've got a class here that's called system.windows.forms.form. And it has things in it like this. Well, when you create your own stuff based off of that, all right, you get this stuff, so to speak, for free. Now, I'm going to show you something that you may or may not have even thought about before. If I come in here and I start up Visual Studio, and as we always do, let's just come up and create a folder in here. And I will call the folder garbage because I don't want to keep it. So I'm just going to call it garbage. And I'm going to come in and I'm going to create a new project. All right. It'll be a Windows Form project. And I'm just going to call it garbage project. It'll be put in a folder called garbage solution. And the location will be in that form, or that folder rather, that I just created. That's called garbage. Okay, no, nothing big here, nothing new at all, but I want you to see something. So it's going to come in, it's going to build this. We're going to have our empty form. All right, there it is. Nothing new here, except when I right mouse click and I choose view code. All right, now you've all seen this before, and you'll notice that the only thing that's in here that is not grayed out is system.windows.forms. Who cares? You should. When you look at this, you may or may not have ever thought of this before. We just created a form that by default is called Form 1. I'm going to change the name of this form here. So I'm going to rename it to FRM Garbage and hit enter. And it says, do you want to change everything? I'm going to say yes. Watch how this changes. See that? It changed here and it changed here. They both had said Form 1 earlier, but now they say FRM Garbage. That's not the big thing. The big thing that we've never really talked about before is this. All right. That means that our FRM garbage that we just created with the colon followed by the word form, that means that it inherits from system.windows.forms. So FRM garbage is a child of a Windows form. So anything that's defined for system.windows.forms is automatically available here. That colon that you see right there, that colon in this case means inherits from or is a child of. So you can read it as FRM garbage inherits from form, or FRM garbage is a child of form. Either way. Now, there's other stuff in here that we'll talk about when we get to the end of this, about chapter 16. And that is things like partial, that we're not going to really get into right now. It's okay. All right. But what we can do, is we can come in here if we want to and right mouse click, and I'm going to come in and I'm going to add. I'm going to go down to class, and I'm going to just call this class parent. Kind of a stupid name, but I'm going to call it parent.cs. All right. So we've got this garbage project. We already talked about this, that we will always change that to public. All right. And we're probably not going to use anything in here. So why am I showing you this? Because in here, we are going to declare what? We may declare some instance variables. We may come in and declare one or more constructors. We may come in here and declare one or more properties. All right. So again, why am I showing you this? Because now, if I come in and I go in and I right mouse click and again add and again choose class, now I'm going to create another class that I'm going to call child.cs. And it doesn't look any different really. Again, I'm going to make this public. But what I'm going to add in here is colon space parent. Now I've literally created a child class called child. So anything that was declared inside of the parent is now available to the child. So any variables that I create in here, so if I come in here and I create, I don't know, private string underscore first name, private string underscore last name. Let's just keep those. And we'll make a constructor in here. So it'll say public parent. And you already know this because we've talked about it. What this will do is this will set underscore first name to the empty string, and it will also come in and set underscore last name to the empty string. We can also come in and have a full arg constructor where we say public parent, and we come in and say string first name, last name, like that. This is nothing new. All right. Plus, if we want, we can come in and add properties. All right. So if we do add properties, if I come in here and say public first name, I gotta see the type, sorry. Public string first name. All right. And I come in here just like, just like it's shown. And I come in here and I put in a get that says return first name and a set, which sets it. And I can do the same thing for last name. What I'm telling you is now all that stuff that we've just done, and I should move that up, I guess, right? All that stuff that we just did in here, it's now accessible by the child as well. All right, but it's done a little bit differently. And I'm going to show you something, and believe me, I'm not trying to confuse you. All right, and we're going to go over a couple of examples of this on Monday. But I'm going to come into the child class now. And in this in this child class, all right, I'm going to come in here and I'm going to add something new. I don't know what. I'll just say private um, int underscore h. Okay. And now I want to come in here and I want to say public, and I want to put in child. All right. Now notice it works fine. It says int age. Hey, but what about all the rest of the stuff? What about the first name? And what about the last name? And etc. What about that stuff? And the answer is we can use that stuff. All right. I don't want to write it in right now because I'm probably will put it in using the wrong syntax, but you're going to see a new word that we're going to use that's called base. All right. But I'm just trying to show you that much of the work that you end up doing in here is going to be based off of inheritance. So there's the base class where you declare anything you want, and any public properties and methods that you declare up here are going to be available down here as well. All right. So as it says here, inheritance lets you create a new class based on an existing class. The new or derived class inherits all the properties, methods, and everything from the parent or existing class. So the child class is called a child class or a derived class. It's also sometimes called a subclass, where the parent class is typically referred to as a base class or a parent class or a superclass. Now, it is possible when you start to go through this, you can have several layers in here or several levels. And a class can be both a child of another class above it and a parent to another class below it. Totally legit. Happens all the time. So as it says, a derived class can do what's called extend the base class. So it can make the child can do things the parent cannot do. Again, it can also replace the way that a parent does some things. And that's typically referred to as overriding. Now, notice it says in here, when you create a new form in C#, this is what I just showed you. The form inherits the .NET class named system.windows.forms.form. Guess what? You already saw that. System.windows.forms.form. So somewhere in this class, all right, that's under system, that's under Windows, that's under forms, there is something in there called form. And there's a bunch of stuff that is put in there that now we automatically get. Okay, and if that still confuses you, you're going to see another example in just a second, because this is how .NET uses inheritance. I don't expect this picture to totally make sense to you, but I'm hoping after we talk about it for a few minutes, it'll at least start to make some sense to you. Okay. Now, back in the day, when I first started teaching, yes, it was a long, long time ago. All right. But the operating system that we used was not Windows as it is right now. Windows is a nice graphical user interface operating system. We use DOS, the disk operating system. And if you've never seen this before, it'd be like if you come in here and you type in CMD and you hit enter, that's the way our interface looked. It was all textual, all right? And it was a black background and white text. Why am I telling you that? Because at the top level, when you were working with anything, if you did this, CD backslash, and you hit enter, that's what was known as the root. That's as high up as you can get on this machine. I can have any folders, directories, files underneath that, but I've now gotten up as high as I can go. That's the root level. The reason I'm showing you that is object is also as high as you can go. So when you start to work up a hierarchy, when you get to the object level, you're at the top. All right. So when you look at this, what do we have? That's called level 0 at the top. In level 1 right here, in level 1, you've got something that's called control. All right. So at level 0, you have object. And at level 1, you have control. All right. Then if you look under control, you'll notice that control has 1, 2, 3, 4, 5, 6 direct descendants. It's got 6 children, and I don't believe this is not probably a complete picture, but it's one that hopefully you can understand. So one of the children under control, so again, if this is level 0, this is level 1, so this is level 2, is called button base. And button base has 3 children: button, checkbox, and radio button. All right. So we're at level 0, level 1, level 2. This is level 3. We've also under control have got a group box and a label. They don't have any children, but we've got a list control that holds both a combo box and a list box. We've got a text box base class in here that holds text box, a scrollable control class that has a container control class that has form underneath it. So that is level 0, 1, 2, 3, 4. So that's 4 levels. And as it says, .NET uses inheritance extensively. All right. And all of the controls are the grand poobah, so to speak. The thing at the top is this base control class. All right. It's kind of like if you had a really huge family reunion and you went up to a certain level. And let's just assume that maybe at the top level, if you kept going up and up and up and up your class hierarchy, you had a mom who didn't even have a husband, but she was at the top. That was the top of the inheritance hierarchy. The same kind of an idea. All right, so you got that object at the top. We just saw this. So because we have object, what do we get for free, so to speak? What does object give us? And the answer is what's in this box here. All right, I did show you an example when we went through the pretest of using toString. It's a way to be able to write things out in a shorter method. It provides the equivalent of a shortcut for us. So we get this toString method without having to do anything. Hopefully you notice looking in here, the stuff we get, they're all methods. Why? Because they all have parentheses after them. So we've got an equals method. Notice it returns true if an object refers to the same instance as the specified object, otherwise false. So in other words, it's a Boolean. There's another equals that says, hey, do these things, are they both referring to the same thing? There's a reference equal. Some of this gets really heavy. The one in here that you're going to use most of the time will be the first one, the toString. It doesn't mean that the other ones are not important. Of course they are. But a lot of what you would use that stuff for, all right, would be at a more higher level of complexity than what we're using to go into this stuff. All right, hopefully what I just said made at least a little bit of sense. So as mentioned here, system.object is the root base for all classes. So in other words, every class inherits either directly from system.object or from something that ultimately inherits from system.object. As they mention here, when creating classes, It's common practice to override toString, sometimes the equal, sometimes you might want to override all of these that are in here. All right, the one you typically don't need to override is finalize. All right, and finalize is sort of, all right, the opposite of a constructor. It's sort of a destructor. So what it says is before something goes out of scope, so if you're not going to use something anymore, you can call a finalize method. You typically don't have to do that because it's handled for you automatically by the operating system of the program. So you don't have to worry about doing it yourself. All right, how to use inheritance in your app. So let's look at that. Again, I don't know if this is going to make a lot of sense or it's not going to make a lot of sense, but let's look at this. These are actually two different examples. Let's look at this top example here. We have been working on this product maintenance app. All right. We did that. In fact, that was our homework assignment for chapter 12. All right. We did a similar one, but ours was an inventory maintenance app. But with this product maintenance app that we're working with, you'll notice when you look in there, it has three different pieces of data: a string for a product code, a string for a product description, and a decimal for a product price. 3 different instance variables. So each product you create should have its own distinct code, all right, possibly its own distinct description, and possibly its own distinct price. In addition, each product can work with this get display text where a string is passed in. All right, so that's the parent. So that's a child of object, but it's a parent in the program. The children now of product are going to be book and software. Books have an author. Software has a version. So now what we're going to see in here is if we create a book product, that book product will have a code, a description, a price, and an author. And if we create a software product, it'll have a code, a description, a price, and a version. And both of them will be able to use a get display text method. All right. Then they show another example here. And what this says is, hey, if we create our own product list, all right, that we're automatically going to have anything that's defined. If we say we're creating a product list that is of type system.collections.generic list of product, anything that's defined in here, I automatically get down here. But if I want to, I can change it around. So notice we got an add in both. All right. Or I can add new stuff or just use existing stuff from a parent. So as mentioned here, you can use inheritance in your applications to create generic base classes that implement common elements of related subclasses. All right. It says it's also common to create classes that inherit classes from .NET. That's the second example. When you inherit a class, you can use the derived class whenever an instance of the base class has been asked for. So basically, a child can do anything a parent can do, but the converse or the reverse of that is not necessarily true. All right, so let's look at some basic skills for working with inheritance. All right, so it says how to create a base class. Well, the good news is you already know this. The bad news is there's a little bit more that we have to think about that we didn't think about before. All right, what do I mean? Well, if you look here, This doesn't look that different from what we've done before until you get down to here. What's new here is the word virtual. All right. What that word virtual for product means is that anytime I create a child of product, and our book class will be a child of product. All right, I'm saying this again. Our book class will be a child of product. All right. And not only our book class, all right, but our software class will be a child of product as well. So what I can do is I can say, hey, what this says in here is when I call get display text on a product, I need the code, the price, and the description. But remember that when we're doing a book, we also want an author. When we're doing software, we also want a version. So that means that we're going to have to override the get display text for both author and for software. Now, the other thing they mentioned in here, when you look at this, is they talk about what are referred to as access modifiers. All right. And really, when you think about this, there's only two of these that we've used this semester. Everything that we've done up till this point this semester, we've either made it public or we've made it private. If it's public, it's available to everyone. And I've even given you examples of like public figures where supposedly at least they're accessible to everyone. All right. You can also make something private where it's only available in the class you're currently in. Now that's sufficed for most of the stuff we've done because we haven't done any inheritance until now. And we haven't really even done that much stuff where we passed information back and forth. But that's going to start changing. Then you'll notice there are 4 other things that are in here. All right. The second one shown here is protected. All right. And what that means is if I declare something in product, if I were to make these protected, for example, instead of public, that means that the parent can change them and so can any child change them. So when you put something in as protected, all right, it's directly accessible and even changeable to not only the parent or the class that creates them, but to any children or child classes of that parent. The other things that you see in here, notice you've got internal and you've got protected internal. And it says for internal, it says available only to classes in the current assembly. And you can kind of look at that as just the ones that are available in your current project. All right. So only the classes in the current project, and you can have more than one class in the current project. All right. You can have protected internal, which as it says is available to the current class, derived classes of the current assembly, or derived classes in other assemblies. So if I had other projects that worked with something, it gets to be a little bit confusing. And that's why one of the things that I provided for you today in here, where I gave you a bunch of these different URLs, all right, one of the ones that I gave you, and I think I did at least, let's see. Well, I thought I did. How's that? But let me show it to you. So if I go out to learn.microsoft.com, all right, and I come out here and I want C#, and again, what I want in here are the different access modifiers. And that was the one. I thought I gave you that one, but I didn't. There's a couple of them here. a reference, and a programming guide. So this explains, as it says, the difference between all of these different types of accessibility. All right. And if you'll notice in here, it doesn't look like there's much, but if you click on any one of these, it'll take you. So if you wanted to know more about protected, you can come out there. And again, there's examples of all these. All right. So again, all I did was I went to learn.microsoft.com and I put in there, again, C# access modifiers. So again, I don't want to sit and read to you. I do enough of that as it is, but you can see in here, all right, the big thing, they specify the accessibility of the members declared by the class. And you can look at what each one of them that's in here. The only other thing I'd mention, because it's important enough to mention again, if you want to be able to override something in a derived class, you must include the virtual keyword. All right. So what we're going to look at in just a second is, okay, now we've got this product class. How do we create this book class? How do we basically set it up? How do we create this software class? How do we set it up? All right, and how do we add a new method or a new property or something? Again, books have authors, software has versions. Now they're keeping it simple. Books could have other things. I mean, books have what? They have authors, they have publishers, they have a number of pages. Software has versions, maybe a software type, maybe a software manufacturer, all right, etc. All right. So as they say here, to indicate that a class is a subclass, you follow the class name with a colon. Now, fortunately or unfortunately, all right, in the next chapter, we're going to talk about interfaces, which are a little bit different than classes. The reason I said unfortunately is the way that you show an interface is virtually the same as the way you set up showing inheritance. All right, there's a little bit of a difference, and we'll talk about that in just a minute. But let's take a look in here. So we can come in here, and this has got to start to make some sense to you. We're saying public class book inherits from or is a child of product. Then we come in and immediately add a new property called author. That means that that author property is available to any book object that we create, but it is not directly available to product. All right. So again, child things that we set up for the children are not directly accessible by the parents, but anything we set up to the parents is available to the child. All right. So here's where it changes. Take a look at that constructor, the public book. Says code, description, price, author. What? What are you talking about here? Then it says colon base, code, description, price. This is probably the most important part of this for you to realize. What this is saying is when you create a book, it is assumed that the book, when you create a book object, you will provide a string for the code, a string for the description, a decimal for the price, and a string for the author. But the code and the description and the price will be passed up to the parent. So the parent constructor will handle setting up the code and the description and the price. The only thing that's in here for this particular right there. So the only thing this constructor handles is the author. The parent handles the code and the description and the price. Also noticed previously when we set this up, I know I'm going back and forth a lot, but it's important. We said public virtual right here, and that set up the code, a separator, the price, a separator, and the description. But now we have override instead of virtual. All right. And we still have that separator, and we still say code. There's no word base in here. It's smart enough to know, oh, code, it's going to get from here. All right. Description, it's going to get from here. Price, it's going to get from here. And we have to provide the author. Now, they even show you another way of overriding this, which involves a little less typing. They both do the same thing. Again, look at this way that it's shown right here, and look at the way that it's shown right there. This is again using that lambda operator that we're going to be going over in more depth and breadth of coverage when we get to chapter 18. In fact, they both use the lambda operator. But notice in here, we specified code with a separator, description with a separator, price, and you probably would have had a separator there too, but it's okay, and author. But here, we've got base.getDisplayText. So what this is doing right here, this is, it's basically doing the equivalent. In fact, it's calling this right here. Now it's a little bit different a concept, and it may take some time for you to have, to be able to wrap your head around what's going on in here. That's why, as I mentioned, I plan on Monday going through and doing a couple examples of these, not ones that are in the book necessarily. All right. Okay. So a constructor of a derived class, so again, that's the child class, automatically calls the constructor of the base class, which is the parent class. So that is called before the child class constructor is called. You use the base keyword to refer to a member of the base class. You use the override keyword to override a virtual member of the base class. You can use the new keyword, all right, if you want to, need to, etc., to provide a new implementation for a non-virtual method or property. I don't think they even showed that in here. All right. All right, I mentioned polymorphism to you earlier, and if you remember, the example that I gave, maybe not the greatest, but I said if a parent defines a speak method, this would be an empty method that would be defined there, that just would say, hey, that means that anybody who inherits from animal automatically has a speak method, but you have to implement it yourself. And as I mentioned before, if I create a dog object, Barfy, Barfy.speak is going to say bow wow or woof or whatever. If I create a cat object called kitty and I say kitty.speak, it's going to purr or meow. And if I create a bird object called Tweety Bird and I say Tweety Bird.speak, it'll tweet or do whatever that bird object does. That's what they're talking about in here. That is polymorphism, which is actually a Greek word that means many forms. All right. One benefit they mentioned here is you can write generic code designed to work with a base class. So let's look at that. This isn't exactly the same thing. You know, it's what I tried to show you is maybe, I don't know, a little bit more straightforward than what's shown in the book. I don't know. All right. But notice what they have in there. They've got the virtual get display text. So the first one that's mentioned in there, you must put the word virtual in it. And what that means is you are able to override or put your own version of get display text in if you so desire. If you don't override it, the only thing you'll be able to print out is the code, the price, and the description. But you'll notice for both the book class and for the software class, we've got the word override, which basically says, hey, call the one from the parent, and that's base.getDisplayText sep, and that'll give you the code, a separator, the price and currency format, a separator, and the description. Then when you get done with that, add a space, and then in parentheses, the author name, all right, or add a space, or a comma in a space, the word version, and then the version number. So they show you, again, how you would use that. And what you'll notice is, in this case, when we call it, we're passing in a string of that means author, and in here, we're passing in a string that means version. Now that string that means version could have also been put in as a double or a decimal if we wanted to do that. So as they mention here, polymorphism is an inheritance feature that lets you treat objects of different subclasses that are derived from the same base class as if they had the type of the base class. If you access a virtual member of a base class and the member is overridden, polymorphism determines what's going to print. That's why, as it says there, the get display text method for the object is different than the get display text method for the book, which is different than the display text method for the software. And as mentioned there, polymorphism is most useful when you have two or more derived classes that use the same base class. That's exactly what they're mentioning in here, in the example that they're showing. So the next thing that they're going to do in here then is they're going to show this enhanced or inherited version of the product maintenance app. So this is going to be exactly what we just looked at. All right. Like the earlier free inheritance version, this is going to use that product DB class that we haven't talked about yet. That's in chapter 17. So they're going to pretty much skip that. All right. But if you look in here, notice we've got a happy marriage, so to speak, in here of books, software, and books. When we click add product, it's going to show us a new product form. Okay. If we use the radio button on the new product form and choose book, this is going to say author. If on the same form we use the word software, it's going to contain version. So we've got two versions of the new product form, and both of them are able to inherit. They both inherit the code, the description, and the price from their parent. Pretty much what we did in the last chapter. So as it says, this version handles two different types of products, book products and software products. The new product form has a radio button that lets you choose between a book with an author or software with a version. The label for the last text box will change depending on which option you selected. They are able, for lack of better words, to kind of live in harmony with one another. All right, I don't know if that's put right, but hopefully at least it makes some sense to you. So the next thing that's shown in here is the code for the product base classes and for the two subclasses. We've already pretty much seen the product base class, so we will concentrate in here on the two subclasses, those being, all right, the book class and the software class. All right, so the product class, as they mentioned, is the base class for the book and the software class. So in other words, it's the parent. And it says really the only big difference in here is the get display text has the virtual keyword in it, where previously we didn't have that in there. All right. The book class specifies the product class as its base class, and it declares a read-write author property. So in other words, it's a property with a getter and a setter. It also provides two constructors. The first is an empty one that will go and it will take the code and set it to the empty string. It'll take the description and set it to the empty string. It'll take the price and set it to 0 by calling the base constructor or the parent constructor. All right, then this one will allow you to, since it's an empty constructor, it'll also set up an author, which will also be the empty string. It has a second constructor in it, a full arg, that lets you specify the code, the description, the price, and the author. To handle the code, the description, and the price, this constructor calls the base or parent constructor to initialize the code and the description and the price properties. So the only thing that this constructor has to worry about, the child, is setting up or initializing the author property. The overridden get display text for the book calls the base get display, all right, of the parent to handle code, price, and description. Then it adds the author stuff. And the software is just the same, except rather than adding an author with a name, it's adding a software version. So when you look here in this public class product, this right here, the only thing that's different in here, the only thing that's different in there, as opposed to what we saw earlier, is, so the only thing different from this public class product from what we saw earlier is that word virtual. It was not shown in there before. When we did it previously, it just said public string get display text. We do that so that in both our book class we can override and our software class we can override to tell it to call the parent in both cases to handle the code, the price, and the description. But we also want to add the author name in parentheses, and we also want to add the word version plus the software version. All right, I'm hoping at least that this at least makes some sense to you. Now, I have nobody with me watching live right now, so if something does not make sense, it will be your responsibility, all right, to get a hold of me and let me know. Okay. All right. So the next thing that's shown in here, as it says, this is the code for the product list class that is used to hold the objects that are maintained by the product maintenance app. So this is going to be our list of products, And what kind of products? Either book products or, what? Okie. And why this thing locks up on me, I don't know. All right. So the code for the product list class, all right, it says this version inherits from the .NET list product class right there. Some books read it as product list is a list of products. Sometimes they say product list is a child of list product. When you work with inheritance, it implies rather what's typically referred to as an is a relationship. What do I mean by that? Well, as an example, a dog is a or is an animal. A cat is a or is an animal. A bird is a or is an animal. All right. A savings account is a type of bank account. A checking account is a type of bank account. An IRA account is a type of bank account, that type of an idea. All right. It says, as this is a brand new version, it doesn't need to define a list product instance variable because the class itself is one of them. All right. We have put in here what? Well, notice the stuff that's in between this curly and this curly. This is the stuff that's different from a typical list product here. Number one, the first comment there, modify the behavior of the add method. Then we provide two additional methods, a fill method and a save method. Remember, what this is doing too is it is allowing us to use two classes that share a lot of information. Why? Because both books and software have a code, have a description, and have a price. All right. This is a product maintenance form. It says the first thing you should notice here is the code for the fill product list box. All right, it says you may remember that earlier we used a for loop. But because this is a product list class, it can use a for each loop, which just makes it work a little nicer. It says you can also see polymorphism at work in here. But let's look. All right. It's going to know based on the information that was provided in the product object, whether it was a book product or whether it was a software product. The reason, again, that is so important is when we look in here, we want to make sure that if it's a book product, it has code, it has price, it has description, and in parentheses, it has the author name. Whereas if it's an if it is a software product, we want it to have the code again, the price again, the description again, but then a comma and the word version and the version of the software it is. You don't want a book product with a version. You don't want a software product with an author. Like I said, I'm just hoping that going over this, and I'm trying to do it slowly, that it at least makes some sense to people. All right. So the next thing that's shown there is some of the code for the new product form. As it says here, you can see that an event handler for the check changed event of the book audio button is used to set the text property. So in other words, it wants to make sure that if you have clicked the radio button, that you are adding the author stuff, and if not, you're adding the software stuff. So book, software, book, software. And that last if statement that you see there on the page in yellow is very important, because notice you're either going to instantiate a new book object or you're going to instantiate a new software object. All right. They're both called product. They're both being handled by the same code. So we're using the same code to display them in the same list box. We're using the same code to check the stuff that's in common. So the same code to check the code, the same code to check the description, the same code to check the price. Then we're coming down here and we're saying, okay, if it's a book, we have to make sure that what's present is an author, a name of an author. Otherwise, we're making sure that what's present is the name of a version. Other than that, it's basically using the same stuff it had before. All right. Now, as we wind down to the end of this, they're going to give you some more topics. I don't know what you'd call it. But this thing in here is going to talk about object type and casting. You can do a certain amount of casting. When we have done casting in the past, we have, for example, casted an integer into a decimal, so we can keep, if we do a division, so that we can keep the decimal portion of it, if we're assigning it to a decimal variable. All right. As it says, the system.object class has a get type method you can use to get a type of object that represents a .NET object. For example, as it says, you can use the name property to get the name of the type. So is it a product? Is it a book? Is it software? All right. And there's other things that can be used in this as well. So if we look here, they're going to give some examples. It says the first example in the figure shows how you can use these properties to display information about an object. The get type is used to get information about a book object. It says notice that even though the variable has a type of product, the type object that's returned represents a book. The second example shows two ways to code an if statement to check for the type. All right. As you know, as software becomes more and more mature, you typically given more and more ways of doing the same thing. So they show in here, again, these are things that you can get from the type class. So the type class has a name property, a full name property, which means it's fully qualified, a base type, so where does it inherit from, and a namespace property. All right. In addition, it has that get type, which returns the type that represents the object type. So if we look at the examples that are here, all right, we create a product. You can see that it's a book. Since it's a book, it needs to have a code, a description, a price, and an author. Remember, had it been software, it would have again had a code, it would have again had a description, it would have again had a price, and afterwards it would have had a version number. Then we say type T equal product.getType. Then we bring in some of this stuff in here. the name, the namespace, the full name, and the base type, just so you can see exactly what gets shown. Again, then they show you a couple ways to check for an object type. The second way most people, especially most newer developers, probably prefer, not even so much because it's less typing, which it is, but it's a little bit more English-like. So it makes it a little bit easier for most people, at least, to understand. So as they mentioned there, every object has a get type method that returns a type object corresponding to the object's type. Now, notice that third bullet. The properties and methods shown here are only some of the more than 90 properties and methods of the type class. So again, there's more here than what's shown. All right, how to use casting with inheritance. We're just about done. Let me check here. Okay, and I think after we get done with the seal, which is next, I think we'll be done. Yeah. All right, so let's take a couple minutes to go over these last two concepts. All right, back, sorry. So, how to use casting with inheritance. It says here, another potentially confusing aspect of using inheritance is knowing when to cast objects. Now, notice it says knowing when to cast inherited objects explicitly. Remember, we have talked about this before, that when you do something explicitly, you, the programmer, does it. When you do something implicitly, all right, implicitly, that means that, for lack of better words, all right, the software is doing it. So it says the basic rule is C# can implicitly cast a subclass to its base class, but you must use explicit casting. Now, just because you can do something doesn't mean it's always going to work the way you think it's going to work. All right. I mean, I can tell an apple that it's an orange. All right. But if I squeeze it, what I'm going to get out of it is apple juice and not orange juice. All right. So they show some examples in here. And they give you two different examples of displaying some stuff. All right. If you go down to the fourth example, it says there's code that throws a casting exception. If you tell the system to do something, so if you tell your program to do something and your program is not software possible to do that, so it's not been written into the software to do that, but you try to do it anyway, you're going to get an error. And that should make sense. All right, you're going to get an error. All right. So as it says here, C# can implicitly cast a subclass to its base class. As a result, you can use a subclass whenever the base class is called for. As it says there, you can specify a book object whenever you are referring to a product object, because a book is a type of product. Then they say there, the second bullet, you must explicitly cast a base class object when a reference to one of its subclasses is required. For example, you must explicitly cast a project object to a book if a book is expected. If you attempt to do a cast the system does not understand, an invalid cast exception will be thrown. You know, I've said this before. You know, when you fight with software, you lose every time. Because if something has been written into the software or not written into the software, and you try to use it in incorrect way in the software's point of view, you lose. Finally, you can use the as operator to cast an object to another type without throwing a casting exception if it's valid. All right. If it's not valid, as it says, it'll simply return null. Finally, the last thing that's discussed in this chapter is working with abstract classes and sealed classes. Now, before we even look at them, I want to mention to you what both of these are. Going back to the examples we did before. Again, I'm saying this, and I'm not trying to be funny here. I don't think what I'm about to say is funny. But let's say that you went out and you bought yourself a new dog. Okay. And your friend called and said, "Hey, what's new?" You would say something like, "I bought a new dog." They might say, "What kind is it?" And you'd say, "It's a golden retriever." "Oh, wow. Is it a pup?" Etc. You get the idea. But there's a good chance you would not say, "Hey, I bought an animal." "Hey, I opened up a bank account." No, I open up a checking account or a savings account or an IRA account, etc. When you create a class, all right, when you start to create a class hierarchy, which is what I'm showing you here, and it's what I'm showing you here, they go from the most general to the most specific. So again, if I went down here and I said this to you before, I might very well have here, let's just say a collie and I don't know, my family has a Bichon Frise, all right, a golden retriever, etc. So again, what am I doing? I'm going from more general to more specific to more specific. All right. It probably would never make sense to create an animal object. A dog object would make sense. A cat object would make sense. A bird object would make sense. But an animal object is just so general or so generic in nature. It still can be a parent, but I'm never going to new it. I'm never going to use the new operator to create an animal object or to create a bank account object. When you get something higher up, typically in the object or class hierarchy, if you never want to create an object of that type, you can put the word abstract there. So an abstract class is one that cannot be instantiated. It can only be used as a base class for other classes to inherit from. To declare an abstract class, you include the abstract keyword in the class decoration, as is shown right there. You can also, if you want to, add abstract methods and abstract properties. When you include those abstract methods and properties, you must override them. All right. So you can kind of look at this, kind of, and this is not a good example, a good definition, because I'm going to give you a better one in the next chapter. But if I say here public class product, all right, and now in here, I've got this, okay, and there's no body in there. This means that everything that's in here is now automatically available down here. Notice though there's something new in here, and that's right here. We have created a new method right there that has public, it has the word abstract, it has a return type of string, its name is get display text, and it has passed into it a string for message, but there's no body in it, just the name. with a semicolon at the end. What this means is I am letting the system know that if I plan on using this, so if I plan on creating a class that inherits from product, I must create my own method in here that is not abstract, that is called get display text. It must return a string and it must take a string in it as a parameter. All right. So as they mention here, an abstract class is a class that can be inherited by other classes, but it cannot be used to create a new or an object. So you cannot new it, so to speak. All right. To declare a class as abstract, you code the abstract keyword. An abstract class can contain properties, methods, and anything else, just like base classes. It can also contain abstract methods and properties. To create an abstract method, you use the abstract keyword and you don't put in a body. To create an abstract property, you code the abstract keyword in the property declaration. All right, then as it says, you code a get accessor or a set accessor or both. Abstract methods and properties, as it said, they're implicitly virtual, so you don't use the word virtual in there. When a subclass inherits an abstract class, anything that's defined up above in the parent as being abstract must be overridden in the subclass. The exception, as it says, is if the subclass is also an abstract class. Finally, an abstract class does not have to contain abstract methods or properties. But any class that does contain a method that's an abstract method, then that class must be declared as being abstract. All right. Finally, the last thing that's discussed in here are sealed classes. So if we go back and look at our examples, looking at the wrong thing up here. There we go. All right. If we decide that we're going to take, let's say, this golden retriever class and we make this sealed, that means that it's at the bottom level. There can't be classes that are created from a golden retriever. Now, if there's 4 different types of collies, there's a border collie, there's a something else collie, and a something else collie, you wouldn't make it sealed. If there's only one type of Bichon Frise and there's only one type of golden retriever, you might make those sealed. So as it says, in contrast to an abstract class that must be inherited, a sealed class is a class that cannot be inherited. Now, many people will tell you that you should, maybe I'm being a little too much here, but really never have sealed classes. Because when you do that, you're saying you can't go down any further in the hierarchy. All right, you can seal properties and methods, but as they say on the bottom, in most cases, the entire class will be sealed rather than specific methods or properties. And finally, it says, keep in mind too, that it's often hard to know when someone else might want to inherit a class that you create. So you shouldn't seal a class unless you give it a lot of thought and you're really sure that's exactly what you want to do. So again, rather than abstract, we use the word sealed. So finally, as it says here, a sealed class is a class that cannot be inherited. To create a sealed class, you code the sealed keyword. Sealing a class can result in performance improvements, but you can only seal a property or method if that overrides a member of a base class. Again, it's not done that often to begin with. You're better off sealing the entire class, not properties and methods. That's it. All right, I am out of my drink and I'm very thirsty. So what I'm going to do right now is we're going to go over this thing on interfaces and generics. It is 9:35. I'm literally going to come back in 5 minutes. And at 9:40, we will go over chapter 15. When we get done with chapter 15, we will go over chapter 16. So I'll be back in a few minutes. All right, it is 9:40, so I'm going to continue. The next chapter has two different things in it, and those are interfaces and generics. We will talk about both. I wasn't going to talk about generics, but we will talk a little bit about them. And I will tell you that, especially with generics, again, it's, in my opinion, for whatever that is or is not worth, it's a little bit more of a complex topic you probably wouldn't use as a beginning developer. Now, as it says, the chapter begins by showing how to use interfaces, which are similar but not identical to abstract classes. Okay? Now, one thing that you cannot do, again, I may have shown you this already. I don't remember. But let's assume in here we've got this. We've got class A, and we've got class B. And underneath here, we want to have a class C. And what we'd like basically is we'd like to be able to come in here and we'd like kind of to do something like this. So what we'd like to do, I'm keeping this as simple as I can, even if it doesn't seem like it, all right, is we would like to have class C be a child of both class A and class B. The short version is you can't do that in here. Even though with genetic inheritance, you have, all right, typically a male and a female, all right, that you are inheriting from. And I know I don't want to get into discussions about other possibilities. It doesn't matter. But the point is, you typically, as a child, inherit from two different parents. All right. But that's actually known as multiple inheritance because, again, you can inherit from two different parent classes or whatever you want to call it. But C# does not support what is called multiple inheritance, where you can inherit from more than one class. All right. It only supports single inheritance. Who cares? Why am I even telling you that? Well, what if I did have something in here and I wanted, it had, for sure, we had to do this. But boy, there's a few other things I'd really like to put in too. Then instead of doing this and making it a class, you make this an interface. Why? Because again, I want to say this again, C# supports only single class inheritance. It does not support multiple inheritance. But C# does support multiple interfaces, which means you can have 0, 1, ... and as many as you want to or need to have. All right. Now, the verbiage you use for this is a little different because you inherit, with inheritance, you inherit. With interfaces, you implement. So you implement an interface you inherit a class. All right. And again, I'm just trying to give you some of the verbiage that goes along with this. So we will talk about interfaces. They can be a thing that can be used. They can be used and abused, etc. Sometimes people should use them and don't use them. Now, then the chapter will end in the last half is it'll talk about generics. And when you use generics, as it says there, you can code your own collections that work in a similar manner to the built-in .NET collections. All right, so we'll talk about all that in here. Okay, as it says, some object-oriented programming languages, C++, not C#, but C++ and Perl allow for multiple inheritance. But C# only allows for single inheritance. In fact, C# and C++ were both built based off of the C programming language, and C allows no inheritance whatsoever. So as they mentioned there, although C# does not support multiple inheritance, it does support interfaces. And as mentioned there, an interface provides many of the advantages of multiple inheritance without some of the problems associated with it. All right, now I believe, and maybe I'm wrong here, yeah, they're going to give you a comparison and compare and contrast the two on the next page. So in some ways, an interface is similar to an abstract class. Both of them can include one or more members that are not implemented. In the case of an abstract class, as it says, the implementation must be provided by the subclass. And then it's similar with an interface. In fact, many books will call an interface a contract. I have mentioned the word contract in here, really more in the AWD1000 class, but with a software contract, what it is it says, hey, I'm going to provide you with A, B, C, and D, whatever those things happen to be. Could be more than A, B, C, and D, there could be less. But you have to agree to use them in exactly the way that I've defined that they should be used. All right. So as it says there, prior to C# 8.0, an interface could not include the implementation for any of its members like an abstract class can. But now it can. All right. What typically does happen as software gets more and more refined, the distinctions between a couple things like inheritance and between using inheritance and using interfaces becomes kind of blurred. In other words, what you can do with one, typically earlier you couldn't do with the other, and now you either can or kind of can, etc. So an important difference between abstract classes and interfaces is that C# can only inherit one class, but it can implement as many classes as you need to. It needs to, so 0 or more. Now, here's that comparison. So again, both can provide signatures for properties and methods that a class must implement. Both can implement some or all of their properties and methods. An abstract method can have static variables, static constant or constants, and it can have methods. An interface cannot have methods. Finally, a class can inherit only one class, but can implement 0, 1, or more interfaces. Now, interfaces typically begin with an uppercase I. So what I'm telling you is you should never create a class that begins with an uppercase I because it's typically assumed that will be an interface. So if I do come in here, don't need this anymore. But if I do come in here, and you've seen this before, in fact, in here, we built child and we built parent. All right. But we could come in here and I could right mouse click and choose add. And again, choose new item and now choose interface. All right. And I will call this, notice it's called interface 1, which I don't like, but it starts with an I anyway. So I'm going to call this I display. .cs. And I can put anything I want to put in here. Notice it says internal interface. It does not say class. Again, you would typically change this to public. All right. So if I come in here and I'm going to put in, I don't know, I don't even know why I would do this, but let's just say public const int inches in a foot equal 12. Don't ask me why I would do that. All right. Now, what does it like here? All right, it says I'm using an older version of C# and it doesn't want me to do it like this. All right, I don't know if I left public off, if it would take that. No. All right. But what I'm trying to get across to you is this. So what if I come in here? Let's say I put in, let's leave the const out. Doesn't like that either. So just int inches equal 12. Will it take that? Doesn't like that either. Interfaces cannot contain instance fields. Show potential fixes. So let's show it. No, that wasn't it. But what I'm trying to get across is this. All right, I'm not sure if it's going to let me put anything in here, but don't worry about it. We are going to look at an example of this. All right, but if I do create something in here, all right, so let's say we put in this string hello. Okay, and notice it's a getter, just a getter only, which is fine. But then if I come back into my let's say my child, I'm already inheriting from parent, but I can put in here comma I display. All right. Why doesn't it like that? Okay, let's talk about why it was giving me an error. Let me get rid of that. It's giving me an error. Why is it giving me an error? Because anything that I defined in this interface, remember, this is a contract. So if I define something in here and I'm going to implement it in here, I must add it in here as well. And it's even giving me a way to do that with the fixes. Well, it was. There you go. So there it is. And notice now the error is gone. Now I wouldn't want to do it like this, but I've got public string hello. All right. So that hello that it's grabbing right there, it has received from in here. All right. So what I'm showing you is in this child class, It is both inheriting a class and implementing an interface. It's pretty much convention. I think you might have to put the inheritance first, and then you put in the interface. And I could have more than one interface. So I could come in here. I could again come in and right mouse click on the project, again choose add, again choose new item, again choose interface. All right, and let's change the name of that because that's a crummy name. We said iDisplay, and this is a stupid name, but I'll call it just so that we have something there. Let me rename here. I'm going to call it not display, we'll call it input. Again, dumb name, but it's okay. Hit enter. Now it's been changed. So I could come in and also from here in my child, I could also implement input. And I don't get any errors because there's nothing in there. So there's nothing for it to actually implement, but I can do that. I'm just showing you here only one inherited. All right, only one class I can inherit from, but multiple interfaces I can bring into the program. It's not really inheritance. So again, in the implement, using an interface is kind of like a contract. All right, now they've got better examples in here than the ones I've just shown you. So on the bottom of the page here, an interface consists of a set of signatures for one or more methods, properties, indexers, or events. By convention, interface names begin with the letter I to distinguish them. All right. So next, some of the interfaces defined by .NET. So .NET uses these. I will tell you this is me speaking, but the ones that I use the most often are the first two. So iClonable can be used to create a copy of an object. You can clone, all right, something that you've created. The iComparable one compares two objects. If the first object is what's known as less than the second object, it'll typically return -1. If the two objects are identical to one another, the contents, it will typically return 0. And if the first object is considered greater than the second object, it'll return +1. All right, so as it says here on the bottom of the page, .NET defines many interfaces that you can use to implement classes. And this table only lists the most important members of each interface. So we went online and we typed in interface, you could see more than this, in other words. This is just, there we go. All right. So figure 15.3 shows you how to create an interface. Well, I've already shown you that, but that's okay. So in this example, notice what they have. What this means, in fact, let's use their example here. All right. I'm going to put this line of code, which says string get display text string sep. All right, I'm going to grab that line of code and I'm going to put it in that input that I just created. There's a reason I'm doing this. There's a reason I want to show you this. So coming back to the input, I'm putting in that line of code. What this is, again, for lack of better words, is it's like a contract. It is saying that any class that is going to implement this interface must put in a method called getDisplayText. It must return a string, and it must have a string passed in as a separator. So I'm getting that error now, and the error is in here. It says, hey, you got this thing, and you don't have anything in here that returns a string that is called getDisplayText. All right, and it has passed into it a string which is a separator. All right, let's just put it here, return the empty string. So notice that now there is no error here. Right? Let's go back and let's look at this. Right? And what does it say? It says child does not implement interface member getDisplayText string. It cannot implement an interface member because it is not public. Okay. Oops, that's not the one I wanted public. I'm sorry. Now, when I do that, now it's coming over and it's saying the modifier public is not valid for this item. All right, so it doesn't like that. And I put public here. Looks like it. And boom, my errors are all gone. All right. Now, you might look at this and go, like, that's all fine and dandy. This is the way that I look at an interface. Okay. That it can be used as a repository. Okay. In other words, one of the things that you can put into an interface, typically, and although it didn't take it from me, are things like constants. All right, so you've got a place where you can put all your constants as an example. So they show you some examples here of how these can be used. All right. So as it says here, the declaration for an interface is similar to the declaration for a class. All right. The only difference is that you use the interface keyword instead of the class keyword. The non-default methods and properties cannot include an implementation. All right. Again, it's more or less a contract. All right. Prior to C# 8.0, all members of an interface were considered public and abstract, and things that were static are not allowed. But with C# 8.0, they are. Unbeknownst to your instructor here, when I basically came in and loaded all this stuff, I loaded, I think, 7.3 instead of 8.0. That's why some of this stuff I'm not allowed to do. All right. How to work with default methods. As it says, prior to 8.0, interfaces could only include abstract methods. All right. And any class that implemented the interface had to implement all the methods of that interface. That's what we're running under because we're still using 7.3. Or at least I am. Fortunately, C# 8.0 provides a new feature known as default methods. Now, as it says, if a class implements an interface, it doesn't have to override the default methods of the interface. Rather, it can use the default methods. Now, we're getting pretty heavy into this stuff. And a lot of people would say, Well, if you're going to do that, then why are you even using an interface? Yeah. There's not a lot of agreement that I've heard amongst different developers, but you gotta kind of look at it this way. Let's suppose that I'm creating an application and I'm creating a class that's definitely based off of another class. But I'd also kind of like to have something that's based off of something else. Well, if that something else is an interface, then it would make sense. It would just make sense then for you to be able to implement it as an interface. All right. All right. As far as implementing an interface, then, as it says here, the next figure shows you how to code a class that implements one or more interfaces. To do that, you code the class name, followed by a colon, a list of interfaces that the class, for the class to use. Note that if a class also inherits another class, you must list that class before the interfaces. So in other words, I do believe very much so that for this child that we did before, that if we tried to change this and put parent on the end like that, okay, notice we're not getting any errors here, okay, because we're not really using anything that was in parent, but we cannot do this. All right, we're putting a class after the interfaces. And it says base class for parent must come before any interfaces. That isn't legal. It must be done like this. Okay, then everything is fine. All right. And I didn't want to get into this in too much detail. We're not really going to use much of it. And if yesterday's test was any example, I think I've already been confusing people with the material that we've been going over. All right, which again is not my desire. So to declare a class that implements one or more interfaces, as it says here, type a colon after the class name. Then list its interfaces that the class implements. If a class inherits another class, you must include it first. We already said that. And you can automatically generate stubs, and they tell you how to do that in here. Typically, it's kind of like what we've looked at before, where you get the little light bulb, and you've got a thing here that the drop down, if it says implement, it'll write that for you. And actually, that's what it did for this one. That's what I chose to have it do. And that's a stub because that's probably not exactly what I'd want to code in there, but there's enough that's been put in there that I won't get an error when I try to run the program. Okay. All right. Now they've got this product class that, as it says, it implements the iClonable interface. All right. It says this example is similar to the example that was shown earlier in the chapter. So let's look at what we have. Well, we've got this product. Now notice, rather than inheriting from a class, we are inheriting from two different interfaces. All right. We still have our empty constructor, our default constructor. We still have our full arc constructor that looks pretty much the way it did before. All right. And now we've got code that, as it says, it creates and clones a product object. All right. Now, Again, why exactly would you want to do this? Well, if you've got a very complex object, cloning one thing from another thing can be very quick, and then you could go in and change what you wanted to or needed to change, as they show in here. So these objects are identical, except we went back in and we changed the code from RDA to PDA. We changed the name from Murox R for data analysis to Murox Python for data analysis. Next figure, as it says, shows how to use an interface as a parameter to a method. So you can pass an interface into a method. Again, and maybe I'm wrong with what I'm telling you right here. I don't know. I was going to check to see if Evan had gotten back to me, and I don't know if he has or not. It doesn't look like it, but I'm giving you this stuff. I'm giving you what I think everybody needs and what everybody can handle. I'm not trying to so over deluge you with this stuff. And believe me, within the next week or so, when we start talking about databases, there's going to be a boatload more of terminology that you're going to have to be introduced to. So you can declare a parameter that's used by a method as an interface type. Then you can pass any object that implements the interface to the parameter. Okay. All right, the last thing that's discussed then in this chapter are generics. As the author mentions here, in chapter 8, you learned how to work with generic collections. All right. The one we've been working with almost exclusively has been a list. Most of the time, as it says, you can use these or other .NET collections whenever you need to work with a collection of objects. But sometimes you may need to define your own type of collection. And that's where generics come in. Since, for instance, you may need to add some functionality that isn't available from one of the collections provided by .NET. Or you might only want to allow certain things that are provided by the generic collection of .NET. So the example that's shown here, as it says, shows a class named custom list T that defines a generic collection that limits the functionality of the list type to adding and retrieving items, getting a count, and producing a string that represents the items. What does that mean? Well, it sounds like, at least from what I can see here, one of the things it does not allow is the removal of items. All right. So when you come in and you create your own generic collection, you are in charge over what it can do. Now, if that confuses you, it really and truly shouldn't. What do I mean? As an example, let's say that I created a person object and I gave that person an eye color, a hair color, a gender, and an eat and a sleep, eat method and a sleep method. Okay. Well, then later on, all right, somebody says, hey, what about drink? You gave an eat and a sleep, but you didn't give a drink method. And let's suppose that class was set up that basically it couldn't be changed and it was sealed. Well, anytime you create a class, that class only has the ability to do what you give it the ability to do. In other words, if you don't give it the ability, a person the ability to drink, a person cannot drink. All right, I'm hoping what I'm saying here makes sense. All right, so they show you how to create this generic collection here. And notice when you create it, you add what it has available. And if there's something you don't want it to be made available to it, you leave it out. So as it says, you can use generics to define a type-safe collection that can accept elements of any type. All right. And I'm not going to spend much time on this. Again, we're not going to do very much, if anything, at all with this. And I don't think we will do anything with it. And they give you some code examples of how this can be used. All right. So again, you got to kind of look at it that if you want to take something that's based off of something else, but either you want to allow it to do something else that whatever you're basing it off of could not do, or you want to prohibit it from doing something that what it's based off of can do, you could create a generic to create your own type of collection. That's the best way that I can really say it to you. All right. So the chapter ends with some of the generic interfaces defined by .NET. And as it says, the generic connect collections are described in the figure. Most of these have corresponding regular interfaces. All right, but the generic ones use angle brackets to specify the data type. If you decide to define your own, as it says, you may want to implement some of these interfaces. So this is some of the stuff that's available to you in here. All right. Now, I already mentioned the I comparable, and that's really the one that I've used more than anything else. Notice there's also, if we go down near the bottom, there's an I list, which, as it says, manages a basic list of objects. Okay. And you've got a I dictionary, which, as it says, manages a collection of key value pairs. Right. So, as mentioned here, .NET defines many generic interfaces, so you can utilize them, add to them, remove from them, etc. The I comparable is the one I've mentioned to you already. Notice greater than 0, less than 0, or equals 0. It's kind of what I told you already. But what you're comparing here are objects, as opposed to like comparing two numbers or something like that. All right. As you work with generic classes, it says you may occasionally encounter situations where you need to restrict the possible data types that it can accept. To do that, you can code a constraint. So if you want to allow only certain things, all right, you can do that. And that's some of the stuff that you can use with these. All right, then they'll go over the IEnumerable. Remember, enums basically will allow you to come in and add your own data type. Autocoded interface that uses generics. I'm not trying to keep anything from you here, but I only want to go over stuff that I think we can all understand. All right, so let me go on and go right into chapter 16 here. All right, chapter 16, again, a fairly short chapter, talks about different ways that you can organize classes and how you can use a class library, which is kind of a cool thing. All right, in fact, I think what I'll do is I'll take what we did earlier and I'll put it into a class library. Okay, or at least try to. We'll see if we can get that to work. All right. So as they mentioned, the last 4 chapters, you learned how to develop object-oriented programs that use classes. All right, now you learn how to organize, document, and test your classes, and learn how to use those in class libraries. As it says, this makes it easier for other programmers to use your classes. Okay, I've run out of water. I'm going to very quickly walk into my kitchen and get some more, and I will be right back. I apologize. All right, so as you can see that the chapter, again, as most are, is split into several sections. We'll talk about how to organize classes, how to document classes, how to create and use class libraries, and just a very little bit on unit testing. So let's get going here. Okay. Now, how to organize your classes, how to code multiple classes in a single file. It is possible for you to have multiple classes in the same file. What does that mean? Well, if we look at the example that we've been using here, we've got public class, child, and all this other good stuff in here. All right. And I think what that means is we could come in if we wanted to and say, for example, public class, child 2. All right. And let's see, we wouldn't put the parens in. I don't know why I did, but I did. And then we'll put in just a couple curly braces. Okay. And what you'll notice is I don't have any errors. All right. And what have I done? I have created 2 classes, one that's here and one that's here in the same file. Now, depending on your point of view, that's either really, really cool, or if you're more like me, you'd be like, all right, well, why the heck would I ever want to do that? All right. Well, the reason that you might want to do that is if you've got a project that's very small, you could put all that information into one file. All right. That's basically the argument that most people give for this. Okay. Now, if you use a class like Java, I'm sorry, if you use a computer language like Java, can you do this? The answer is sort of. And what I mean is you can take a class and put it inside of another class like we have here, which we'll talk about in a minute. But in Java, unless they've changed it since the last time I've taught it, which was about 2 years ago, but unless they've changed it, any class that's inside of a public class must be a private class. So you can't have 2 public classes in the same file. All right, you can do that in C#. Or as I just mentioned, and as they show here, you could have a class within a class. Okay. Those are known as nested classes. All right. And again, as it says, when 2 classes are closely related, it may make sense to code them in the same file, especially if they're small. One way to code 2 classes in a single file is to list them right after one another. Another way to code them is to nest one class or put one class inside of another. As it says, this is useful when one class is used only within the context of another class. To refer to a nested class, you must qualify it with the name of the class it's nested within. All right. Now, this next section, starting here on page 524, it goes over some of the stuff that I've sort of mentioned earlier, and that is if I go up to here, let's get rid of this class because we don't need it. All right. But if you come up here and let's go to our FRM garbage. Remember this? Time to talk about that right now. When you create something, all right, when you create a form, for example, in here, it's always created as a partial class. And I believe at least the main reason for that is if you wanted to, if this particular form got really huge, you could put it in multiple classes. And when I say multiple classes, multiple partial classes of the same name. All right, I've never worked on a project that's been that voluminous that I've had to do that. But as the author says here, this figure shows you how to use partial classes to split a single class across multiple files. So to do that, you just code the partial keyword before the class keyword. And they're going to show this. And again, as I mentioned, it says if a class you're working on becomes very large or different programmers are going to work on different parts of the class, the use of partial classes can really make a lot of sense. Visual Studio uses partial classes to separate the code that's generated from the form from the code that's entered by the programmer. So you've been using them all along. All right. Finally, it says C# also allows you to code partial methods within partial classes. Partial methods are used to implement methods similar to events. All right. So when we look here, notice the first file says public partial class customer. The second file says the same thing. All right. And you can also, as it says, split a form class. So this says public partial class form 1. This just says partial class form 1. So as mentioned here, partial classes can be used to split the code for a class across several files. All right. And to code this partial class, as mentioned here, you enter the partial keyword before the class keyword. All partial classes must belong to the same namespace and the same assembly. If the class you're working on becomes very large, or again, you want different programmers to work on different parts of it, you can use partial classes. And again, C# in the same way uses a partial class to separate the code that's generated for a form from that generated by the programmer. All right. Another thing that's in here that we've never really talked much about before has been a namespace. As it says, a namespace is a container used to group related classes. All right. Now you may or may not have noticed this, but if we take a look here, go back to here. All right. This says namespace garbage project. If I go to here, namespace garbage project. If I go to here, namespace garbage project. If I go to here, same thing. If I go to here, same thing. If I go to here, same thing. And this is just my form. All right. The namespace by default is going to be the name of your project. All right. So as mentioned right here, the namespace is the container used to group related classes. Every C# class you create must belong to a namespace. As it says, it's identified by the namespace statement. All right. When you create a C# app, Visual Studio creates a namespace that has the same name as the project. You can also nest namespaces. In fact, as it says, most of the .NET namespaces are nested. You can read that yourselves. I'll leave that up there for a second. Finally, it says, although all of the classes of a project are typically stored in the same namespace, those classes use classes that are stored in other namespaces. For simple C# projects, you don't need to worry about namespaces because Visual Studio takes care of how they're set up for you. And I'm not saying that what we're doing are necessarily simple projects, but in the realm of things as opposed to something that multiple developers are working on that could be thousands, if not hundreds of thousands, if not millions of lines long. Yes, what we're doing is more simplistic. All right. It says the next figure here shows you how to work with file scoped namespaces introduced in C# 10.0. So when we look at this, all right, since it doesn't even pay really for me to get into this because with the version I'm using, we can't use this anyway. But they do show you what they are and how to use it in here. Again, I am not trying to hose you or keep anything from you. All right. All right. So what's next is how to document your classes. You already know this, that if I come in here and I come in to view my code, and let's just say here, I'm going to, you see me do this global constants. And then we put our constants in here. So again, if we wanted to say const int feet in a mile equals 5,280 to my knowledge. Not a problem, right? The point is this. You've also seen times where I have grabbed some code and put in, for example, at the beginning of the program, some kind of a prologue. So program prologue goes here. This program allows the user to, and then have, a bunch of stuff in here. And finally, we end it. The point is, this is single line internal documentation. This is multi-line internal documentation. But, and I did this a couple weeks ago, you may or may not have seen it when I did, but if I put in 3 forward slashes, you may or may not have noticed, okay, but right now, this is not green. It is gray. All right. When you use 3 forward slashes, you are putting in XML documentation. Now, some of you have already heard my shtick about XML, but if you have, you're going to hear it again. And if you have not, you're going to hear it for the first time. XML is an acronym. It stands for Extensible Markup Language. Now, I believe it was around sometime in the 1980s. I could be wrong, but I think it was around there that somebody came up with the idea that HTML, the hypertext markup language, no longer was basically, it had outgrown its usefulness. Okay, it was the language of the web, but it had outgrown its usefulness and something else needed to be created. Something that was more extensible, that you could do things with that you couldn't do with HTML, because HTML has about 100 to 120 tags. And unless you added a ton more, that's basically all you could do with it. All right. Plus, what you could not do with HTML was to create your own tags. So somebody came up with the idea of creating this extensible markup language, XML, where you could create your own tags. All right. There are at least, from the last time I heard, there are probably at least a couple hundred different types of XML out there. For instance, there is math XML, which allows you to talk about mathematical operations using that language. There is music XML. There is chemical XML. All right, there's all sorts of different kinds of XML. All right, well, let's just get back to the topic at hand. And as it says, you can add comments by using comment statements within slashes, all right, or / ending with //. But as mentioned here, you can also use a documentation feature called XML documentation to create documentation for the classes and class members that you create. All right. there are certain ways that XML documentation is used in this language. As they mentioned there, although XML documentation is based on XML syntax, you don't have to really know XML to be able to use it. There are many good articles out there. And let me just tell you too, for the rest of that little quick story, which wasn't that quick, on XML, and that is the fact that XML never became quite as popular as people thought it would be. And in the mid 90s, people gravitated back towards HTML and kind of started gravitating away from XML. That doesn't mean XML is gone. It's not. It's still used by a lot of things. Those of you, or when all of you take the AWD1100 class, which is database-driven web development, and you learn about what's called the MERN stack, all right, which is MongoDB, Express, React, and Node.js, especially with Node.js. All right, much of the stuff that you will do used to be done a lot using XML. All right, not so much today. More today, it uses JSON, but I don't want to even get off on that and talk about that. So, all right. So these are the things that you can use in here. Why might you want to use this? It is possible for you to go and parse out and just look at basically the XML comments that are in your document. So notice there's not that many of them. Summary, value, returns, and param name. Okay. Now, the summary is just that. It's, I've been using the summary, which I call the prologue. All right. But as it says, it's designed to provide a description of a class, a property of a method, etc. So you could have lots of summaries in here. It's another form of internal documentation. Anything that you do with XML documentation, you could do with non-XML documentation, which is /* and // or which is double slashes. But these have a very special meaning. All right. For instance, with the params, this would show you could put in there exactly what parameters were being provided to a method, the type they were, what should be returned, etc. All right. And so this is using both the param name and the returns in here. It's another way of providing internal program documentation. All right. All right. You can view it as it says, Visual Studio. All right. Once you've added it, you can bring it up in Visual Studio. All right. One of the things that's in there, it's not right here. I don't know exactly where they'll show it or if they do, but when we looked at some of the stuff we've looked at in here, there are different ways when you bring up different viewers in here that one is an XML viewer. Okay. All right. The last thing that's in there in this chapter is how to create and use class libraries. Okay. So far, all of the classes that we've created have been inside of every project that we've created. So in other words, we wouldn't be able to share those between two different classes. If you want to be able to create classes and share them amongst several projects, you use a class library. So as it says, simply put, a class library consists of a collection of related classes. You could have more than one class library. You could have, make it generic. So I could have, for example, if I created my own math, different things that I wanted to be able to do. All right, maybe I wanted to extend some of the stuff that you can do um, in C# itself, and I've made my own functions and stuff. I could put those into one or more classes and put those into a class library. All right, then I'd be able to share them without having to copy them into each project. So as far here, as they say, as far as class libraries and how they work, says the next figure illustrates the difference between using classes created within a project and classes within a class library project. Classes within the form project must be included directly in every project that uses them. But if they're in a library, they can exist separately. So they can be made available to any class or any project with access to that library. Now, I was trying to think of a good or at least a decent example or some kind of an analogy to this. And back in the day when I was your age, if I wanted a book from a library, um, I'd go to the library. They didn't have that book. I was kind of hosed. I mean, I was kind of stuck. In other words, you didn't have libraries that had agreements between them that if I was in O'Fallon, Missouri, and I wanted a book and it wasn't there, but it was in the Wentzville library, where they could just check on their computer, contact the Wentzville library and have them send it, all right, to the O'Fallon library. Well, that's kind of what a class library is, all right? Since, it's kind of like you've got this thing available that anybody who's got access, so anybody who's part of that library system, for example, can use. And as they mentioned there, one of the benefits is the size of each project is going to be reduced because you only need a reference to the class library. You don't need to load the class library itself in. So the program will compile faster and it'll be smaller. And another benefit is maintenance. If you discover that you want to add something or change something, etc., you change it in the class library. And once you're done, that modified library is then available to anybody who needs it. But the biggest benefit, as they mentioned in the bottom paragraph, is the concept of reusable code. All right. Now, this is a great example, even though it may not look like it, it is. We have created several projects. We have created several projects in here that have used that validator class. But every time we've created a project that uses the validator class, we've had to go in, sometimes retype it or whatever, or at least copy it in or do something. All right. Well, that's not a good way of doing things for the same reasons we just talked about on the previous page, such as what if I decide I want to make a change in one of the validator functions? Maybe we didn't put a validate Boolean in there. And now we're starting to do more and more things where we need to validate something is Boolean. Well, do I want to really put it in one class and then copy it over to every other time I need it, etc.? Maybe I forget once or put it in wrong once. Or do I want to be able to put it in to a library, add something new or modifying something existing, boom, everybody can use it. So as it says here, class libraries provide a central location for storing classes used by two or more applications. When you store a class in a class library, you don't have to include the class in each app that uses it. Again, changes are immediately available to all apps that use the library. To develop a class library, you create a class library project. Then, when you build the project, Visual Studio creates a DLL file for the class library. DLL is a dynamic link library file. All right. And let's talk for a second what that even means. All right. You've seen this stuff. This is the same project I've been working on. And I created a couple of these, but let's suppose, all right, I wanted to create a class library, just forgetting all this junk I have in here now. We don't care. All right, so let's just suppose we don't need this child. I'm just going to delete it. We don't need it. We don't need this iDisplay. We don't need this iInput. We don't need this parent. So in other words, right now, whoops, right now it is pretty much looking the way a standard project would look, except I put a constant in here. All right, we don't need that either. So let's get rid of that. All right. Now we decide that we're going to create a bunch of different classes for this project. And we're going to create them in such a way that ideally, eventually, we will be able to use them in multiple different projects. So rather than doing this, where we would right mouse click on here and choose add and go to class, which we can do. But then for lack of better words, that class is kind of tethered to the project. So let's not do that. Instead, not to our project, but let's go to our solution here. We're going to our solution here, and we are going to do a add new project. All right. And you might say, well, we've done this before. Not like this. Up here, I'm going to type in class library. And lo and behold, there it is. So I'm going to go to C#, and I've got to give it a name. All right. I'll just call it Jeff's Library, which is a stupid name, to be honest with you. Okay. And it knows the location, but that's fine. So I'm going to say next, create. And now it's asking me here what version. And again, I wish I would have loaded a later version, but I did not. So I'm just going to click create. And nothing magical is going to happen, except I now have a thing in here that's called Jeff's Library, and it comes with a class in here that doesn't do anything. So typically what most people do when they start is they get rid of this class. Okay, so I'm going to come in here and I'm going to delete this. Cool. So now I've got this, just Jeff's Library. Now I'm going to come in here. All right, and it's going to sound a little stupid what I'm going to do, because it is a little stupid, but just to show you something. All right, I'm going to right mouse click on here. I'm going to choose add. And again, I'm going to choose class. And we'll just give these very generic names. So class1.cs. All right, so there's Jeff's Library. Notice the namespace. All right, I'm going to make this public. And to keep it simple, all right, I'm going to come in here and just put a public class 1 like that, just like that. All right, so I've got, and I don't want that. I want that. Okay, so I've got that. And let's put in here, I don't know, I'm going to put in here a string for a name. Okay. We'll make it, let's do it like this. We're going to say private string name. I'm trying to keep this really, really simple. All right. And I'm going to say here public since I'm trying to keep it as simple as possible. Let's use getters and setters. So we won't even use this. All right. So I'm going to say public string. We'll say it here. First name. Again, this is not a great example, but it's the one I'm going to use. All right, that's all I'm putting in here, and we'll put a last name in here too. Okay, so we've got those. We got a first name and a last name. That's all I'm putting in here. That's everything that's in class 1. Now it says no nullable property must contain a non-null when existing constructor. All right, we can say in here equals string dot empty. And I think if we say it for the other one, all right. Let's see what doesn't it like. Does it want a semicolon at the end of each of these? Okay, now I've got no errors, no warnings, no nothing in here. See that? Okay. All right. So there's the first one. Fine. I've created a class that's got first name and address and last name in it, and that's it. Okay. Now I'm going to do a file save all on this, and I'm going to come in and I'm going to create a second class. In fact, we'll do it like this. This is fine. Now we're going to add a second class that we'll call class2.cs. Again, we're going to make it public. All right. I'm going to go back to my class 1 here, and I'm going to get rid of that. And now I'm going to bring that in, but I'm going to change some stuff in here. So I'm going to call this, not that. I'm just going to make one field in here, and it's going to be public string address. All right, with another get set. Now I've got 2 classes, class 1 and class 2. Okay. Now I'm going to go back and add one more. Doing this off the top of my head, so I sure as heck hope it works. And this will be class 3. All right. And let's go back to here. Grab that. All right. And I'm going to put in here city. And I'm going to put state. And I'm going to put zip. All right. Very simple stuff. I'm not doing anything here that's hard. All right. Now I've got 3 classes, one that'll allow me to put in a first and a last name, one that'll allow me to put in an address, and one that'll allow me to put in a city, state, zip. Would I put these all typically in the same class? Of course I would. All right. Now what I want to do is I want to come up to right here to my project, that garbage project. I'm going to right mouse click and I'm going to choose add, but I'm going to try to find here reference. Okay. All right. Now I'm going to come in here and I'm going to look under projects and notice there's Jeff's library. So if I click on that and I click OK, all right, now if I want to be able to use something from, let me do a file save all here. And I'm going to close here class 3 and class 2 and class 1. All right. But now in here, if I do a using and I look at what's in here, I better go follow the steps in the book instead of my own because I'm probably going to screw it up. All right. Let's see how to create it. So I showed you that. You use the class library template that's available in the create a new project dialog. After you enter a name and a location for the project, in the configure, you select, okay, Visual Studio creates a class library with a single class named class 1. All right. Now it says at this point, you can enter the code for this class and create additional ones. Or, all right, it says if If the classes you want to put in this library already exist in other projects, you can delete this class one class file and do a project add existing item. Well, I did a project add new item. All right. But let's see. This says, let's see if we can do this. I don't know. Let's see. All right, I'm going to try to do something. Again, I'm doing this all off the top of my head. That's cool. No problem with that. Get rid of that using statement. All right, I'm going to go back down here to my Jeff's library, right there. I'm going to right mouse click on here. Let me close this. I don't need this thing here. I'm going to right mouse click on here and choose add and choose existing item. All right, well, it assumes it's in the project here. It's not. So I'm going to go back out, and on my desktop, I'm going to see if I can find something. Here's emp test and solution. And I thought I had validator in here, and it looks like I don't. I could bring an employee if I wanted to do that. Let me see if I can grab something else. Boy, oh boy, Jeff, try to find something when you need it. If I can't find one soon, I'll just stop and tell you what I'm trying to do instead of just fumbling my way through here. Let's do it like this. Okay, there we go. All right, I'm just going to grab this validator that's right here and add it. So what you'll notice now is what I did was I went out and into my class library. I just brought this in. All right. Now, is that cool? Not exactly. All right, not exactly. But what is cool about it is that I'm able to go in and just add an existing class to a class library. Now it says that this does not exist here. Let's just remove that. All right. So you can either add your own classes to a class library. You can bring in existing classes to a class library. Okay. And that's pretty much what they showed in there too. They went in there and they copied it in. Okay. So again, to create a class library project, display the create new project dialog. I did that. Then select the class library template. We did that. Enter a name and a location. We did that. By default, a class library contains a single class named class 1. You can modify that class. You can delete the class like I did it. So there's a lot of different stuff you can do with this. You can add new classes or existing classes. I showed you how to do both of those. You should create a namespace for your class library that indicates the purpose. All right. They do a better job than I did. They use Muroc validation. Okay. If you add XML documentation, you will need to generate a file that contains that first. That's no big thing. To compile a class library project, select the release. Well, you can compile it first if you want to make sure there are no errors in it. All right, this is what I wanted to show you is how to add the reference. So the next figure shows how to add a reference to the class library so you can use its classes in an app. To add a reference, you use the reference manager dialog. From this dialog, you can select or use the browse page. So let's do that. Right, it's pretty much what I showed you. So, but let's go over to here. And in our regular project here, all right, I don't want to be using this. Sure, I want to save it. All right, but back here, if I choose add reference, and I showed you that before. All right, we've got shared projects in here. And I think we've already done this, so we clicked OK. All right. I'm missing something here, but it's hopefully it's going to come back to me. And then we want to say using. All right, to simplify that. Add a reference by right-clicking dependencies in the Solution Explorer. So let's follow their steps so you can see me try to work my way through this. Right mouse click on dependencies. All right. And choose the add project reference command. So right mouse click, add project reference command. Right. In the box that comes up, display the browse page. Click the browse button. Now let me cancel this. Move this up so we can see all of it. Locate the DLL for the class library, select it and click the OK button. Well, for some reason it wasn't working the way I thought it would, but let's check it out anyway. So, how to use a class library. Add a reference to the class library to your project. Okay, I'm at my project. By right-clicking dependencies in the Solution Explorer. So I think I did it wrong. So let's try it. Right mouse click on the project. All right, build dependencies, project dependencies. It's got it set up as being Jeff's library, so it looks like it's set up already. If the class library product is included in the same solution, that project will appear on the project's page. Then you can add a reference by selecting the project name and clicking the OK button. All right. Okay. See, I don't want to add a dependency to itself. I've done this before. I don't know why I'm having a problem, but I am. Should have done this before class. All right, that is the last thing in here, but I want to do it so I can show it to you. All right, let's look and see if we've got that actually into our thing here. Whoops, sorry. So let's go to our project, look over here. Under dependencies, it does not have it. So I'm going to right mouse click. Choose add project reference. In the reference dialog, display the browse page, locate the DLL for the class library, which it didn't have. So there's nothing found in there. Selecting the project name and clicking the OK button. Well, the name of that project was Jeff's Library, but it's not showing in here. I think the reason is I haven't built it, so I don't have a DLL in here. So let's look. So again, we have to go back into here, not into there, into here. Well, that would help too, wouldn't it? Okay, I'm going to click build here under my library. Close all of this. All right, so I just right mouse clicked on it and I chose build. And it should have, hopefully it's built something for me. Now I'm going to go back to here to my garbage project, right mouse click, choose. Okay, well, I'm doing it wrong, so I'm going to go back and review that again later. Okay, now just about finished. I will go back. I promise you that I will go back and look at this and fix it, show you what it is. The last thing that's in here is on unit testing. And as it says, so far, you've learned how to test a project by you build it, and as you're building it, hopefully, you're running tests on it with validated and invalidated, make sure it works the way you want it to work. Unit testing, as it says there, provides a way of testing individual methods. So you write unit tests for every method in there, all right? And the goal is actually to make it fail. Because if it fails, then you know you've got to go back and debug it because something is incorrect in it. All right. So what unit tests do is they can help you identify problems as early in the development cycle as possible, because the earlier you find a problem, the cheaper it is to fix it. You can also run these tests anytime you make changes to code, so you can make sure that what you're doing works. All right. So By default, Visual Studio provides for creating 3 types of tests for projects: M-test, X-unit, and N-unit, and they use M-test in the example here. So they show you how to go in and create a unit test project rather than doing this, because I think I should go back and look at it first so you don't see me flounder my way through here. We will pick it up here. So on Monday, what I will be responsible for is going back and fixing the thing with the class library and doing this with you. All right. Now, no, I'm not quite done yet. What I will have to do this weekend is take a look at what is in here in your homeworks. So both in the extra exercises, all right, you'll notice that there are several of them. There's one for 14, two for 15, and 2 for 16. I'm going to look through those and see which, if any of those, I'm going to assign. Then I'm also going to go in and take a look under the projects and do the same thing. See if any of these projects make sense to go over. All right, so we will do that on Monday. In addition, I'm going to create a couple projects that we will work on as a class. Okay, that's what I had today. If I talk to Evan and he says, you really should go over chapter 13, I'll do that on Monday as well. All right, that's all I have for right now. Have a good day. I will talk to you soon. All right, so today we went over, John, just so you know, we went over chapter 14, chapter 15, and chapter 16. A little bit of a glitch at the end of chapter 16, which I'm going to fix. All right. Also, I have not graded any test. Out of the people who took the test, I'm hoping at least everybody has finished the test. All right. But if it turns out that people didn't do very well, then what we'll do on Monday is I will do the entire test in front of you from scratch. I have no problem doing that. If I do that, I'll save it as a private video and send you all invites. All right. From there, if we have to do that, fine. And if we don't, we'll just go on. But what we're going to do then is I'm going to go over a couple programs with you that are not in your book that I've already written, so we can hopefully really get a good grasp on the idea of just exactly what is inheritance in this. So what we talked about today in here, just an FYI, all right, is we took a look at what was in here and said the following. I think you may or may not agree with this, but I think we've done a pretty good job of going over the first 12 chapters in this book. Again, you may agree, you may disagree. I skipped chapter 13 because I don't think with the stuff that we're doing in this class, we're ever going to work with indexers and delegates, etc. All right. So I may go over it again. I don't know. But for now, at least I skipped it. Today, I went over chapter 14. We started with that and looked at inheritance. After that, we went over chapter 15, spent more time on interfaces, and talked a little bit about generics. We ended up today going over chapter 16. I have sent my counterpart, Mr. Gudmested, my counterpart in St. Louis, an email saying, this is how I want to do this. Because by the end of next week, all right, I want us to have a test on this, which will probably be almost solely on chapter 14, very little bit on 15, and maybe have you use a class library from 16. Then I want to immediately get into 17 and 18. We're going to spend a class period, part of a class period on 17, but more on 18. And then boom, jump into the last section of the book. Next week, we're going to do two things in addition to all the other stuff I mentioned. If this is your first class at Rankin, you are responsible for doing an electronic portfolio, just so you know that. We probably mentioned it at the beginning of the semester. All right. So what will that be? Just to very, very quickly show you an example. Here's an example of one that I've created for students. Okay, that's me. That's my granddaughter. She's 6 now. So that's an old picture. But you'll notice if we do this, I can go down to, I guess I didn't have those linked. All right, so but I can go down here. What can I do? Here's examples of some projects. All right. A little bit about me. Of course, that's not me, but you get the idea. I could put my resume in there, a contact me page, and some more contact information. I'm going to show you how you can literally go out and get free software, the stuff I'm using here, download it on your system. And what I will do is I will build an electronic portfolio similar to what you will need to do by the end of the semester. And literally, I'll do it in about 10 or 15 minutes. That's how simple it is to use this software. All right. That's one thing we're going to do. The next thing we're going to do is I am going to give you some requirements for an end of semester project. I want to clear this with Mr. Gudmiston to make sure this is how he does it, but I believe it is. To my knowledge, when we go over chapters, next week, if we have a test on chapter 16, that very well may be the last hands-on test you have. All right, in lieu of a hands-on test for 17 and 18, and for 19, 20, 21, and 22, you will have this project to work on. This project, I want to give you the requirements for it next week. It will be due the day before the end of the semester, which means it will be due 6 weeks from yesterday, August 16th. The reason I want to do the day before and not the day of is in case something is wrong with it, or I can't read it, or whatever. I want to be able to get a hold of you and give you time to complete it, finish it, etc. So next week, we will be through chapter 16 in the book. We will have done several examples. All right. We will go over how you do your electronic portfolio. I will also show you with this electronic portfolio how you can put it on GitHub in something special in GitHub called GitHub Pages, where you can make this thing available to the world. All right. And then finally, I will give you the requirements for the last, for your project for the rest of the semester. So that's what we're going to be doing next week. All right. With that said, that's what I had for today. All right. I will grade your stuff this weekend. If it turns out that by and large people did very poorly on it, then I'll be more than happy to do the test as a class. All right. And have you watch what I'm doing. Now, if you think, well, I got mine done and I did okay, or I got mine done and I didn't do okay, send me an email and just say, hey, I'd really like to have you. I'm having a hard time with this. I'd like you to do it in class so I can see what I may be doing wrong or what I could have done better, etc. If I don't hear from anybody, if I get no emails from anyone, and it turns out by and large people did fine on the project, then I'm not going to do it in front of you. I don't want to waste your time. All right. So with all that said, a little early today, but that's really what I have. So have a good day, and I will talk to you next Monday.